Okay, now I want to challenge you to see if you can work this problem out and write it as one trig ratio. Let's do it step by step. Take a second and see if you can separate the problem and then rewrite it in terms of sine and cosine. Go ahead and pause the video. Okay, is this what you got? Let's talk about what I did. So I separated the fraction numerator and denominator, and I ended up with the numerator part, the denominator part. We're pulling this out. I got 1 over sine squared of theta times secant squared of theta. And then I multiplied it by the numerator, which is secant of theta minus cosine of theta. Rewriting this in terms of sine and cosines because I really didn't have anything to go with. When I rewrote it, I had 1 over sine squared of theta times 1 over cosine squared theta. Now then I'm multiplying this expression times secant of theta, which is 1 over cosine of theta, minus cosine of theta. Okay, so guys, the next step is to simplify this out. We got a super fraction over here, and then we got two fractions being subtracted over here. So take a second and pause the video. See if you can write this in simpler terms. All right, what did you get? So if you looked at this, did you look at this fraction over here and notice that you can combine, you're multiplying these two expressions together, and I'm noticing I even forgot to write my squared on here. Okay, there we go. Okay, so you're multiplying these two expressions together. So what I did is just multiplied those and put them together as one fraction. So I had 1 over sine squared of theta over cosine squared of theta. You know we're going to be doing a keep, change, flip in a second here. Over on this side, I just went ahead and subtracted the fractions, which means I needed a common denominator. My denominator is going to be cosine of theta, which I had here. And that means that the only fraction part that I have to really work with is this one. I got to put cosine of theta in the denominator over here, which means I need to multiply top and bottom by cosine of theta. When I did that, I would end up with my common denominator, cosine of theta, and in the numerator, I would have 1 minus cosine squared theta. Okay, now let's keep on moving forward together and let's simplify this. Notice over here, this is that keep, change, flip situation. I got a 1 over a sine squared of theta over cosine squared of theta. So this will flip this, right? This is just saying 1 times the reciprocal of this, which would be cosine squared of theta over sine squared of theta, okay? Then I'm going to be multiplying this by 1 minus cosine squared of theta over cosine of theta. Now, let's take a second because it looks like we don't have much going on here. Let's take a second and see if we can simplify something. This looks good. Over here, though, 1 minus cosine squared of theta. Again, we're calling our Pythagorean identity the sine squared of theta plus the cosine squared of theta is equal to 1. Remember, we can subtract over the cosine, right, squared of theta, and rewrite this another way. Cosines cancel, where we end up with sine squared of theta equaling 1 minus cosine squared of theta. So I know that I can substitute for this 1 minus cosine squared of theta, I can substitute sine squared of theta. So really our problem is the cosine squared of theta over the sine squared of theta times just sine squared of theta over the cosine of theta. Oh, there we go. All right, when I do that, looks like we can cancel out a lot. Okay, so over here, these sine squareds cancel. And then across this way, I am going to get rid of one of these cosines. Okay, so this cosine cancels. So this whole fraction ends up being 1. And over here, one of the cosines go away. So I just end up with a cosine of theta times 1, which is just cosine of theta. We have simplified this to one trig ratio. All right, let's move on to the other problem.